Hey everybody, welcome to the stream. Hopefully everything's working. I just kind of did everything last second today. How's everyone? So just wanted to show, I guess real quick before we start, what the state of things are. This is the newest knuckle. I didn't print it quite properly. My printer's, oh, there we go. Having some snacks. Yeah, I wish I had some snacks, but for some reason, my snacks don't last very long in the house. I think someone's stealing them when I'm not paying attention. But yeah, this is the stuff we worked on last week. These are the two control arms. Lower being the longer one, which goes in here. Upper being the shorter one, which goes in here, what I love is that they are symmetrical. This is the subframe, which is broken because my prototyping filament is trash, but that's why it's prototyping filament. Yeah, look, everything is just breaking off there. But what it told me is the dimensions look right. I may want to open up this a little bit for the axle to go through, but I think it'll work just the same, so that's good. So yeah, that's that. Now today, there's two things we can work on. One is the drive shaft, which is all well and good, but that's going to be difficult. So it's going to be taking this piece that we have already and sort of, if I can give it a quick trace there. So it's this piece that we already have, and then it's going to have to end up in a cup, sort of like that, and then inside accept another cup, sort of like that, and then out to a drive shaft piece, and then basically this is going to be splines on the inside so it can flex and still deliver power. But in order to keep it sort of forced in there, the drive shaft will have to be two parts. So this is the kind of like, let's say one part, and there's another part that'll keep going like this, and with a chamber in here, and then it would have like a spring sort of going this way to hold it together. Now that spring, I'm hoping it's going to be 3D printed. How's it going, Franco? But yeah, to keep basically pressure on this way and this way, so it sticks in the cup on the other side too. So yeah, that's going to be quite the engineering challenge for me, especially not being that great at CAD work. But I'm willing to give it a shot. So that's decent. So drive shaft, at some point it'll have to be done. I don't know if I quite feel like doing that today. The other thing we need to work on is the wheels and tires. So the wheels and tires, that should be pretty simple. We have a 17mm hex in the middle, so sort of like this. Whoa, that's an octagon. That's not good. So 17mm hex, a sort of flat disc to accept a washer, because the bolt comes through here, then it has a washer through it. Have the bolt over here. What's cool is I noticed that we can actually get these bolts hollow as well, so I can make a lightweight version. But basically this is the bolt here, so bolt, washer, and this will go through. You can see my axle there. This is gonna, that needs to be a bit bigger, but that's gonna fit through here. Bolt's gonna come through, and then the wheel's gonna thread on, and then put this thing on the outside. Oh yeah, and I've got lock washers as well, so this can be used as the wheel nuts. So yeah. Yeah, I've noticed that we can get these hollow online, which is really cool because this is really heavy by itself because it's all steel. And so the hollow versions be a lot lighter, which means that anybody who wants to do this design can just print this out and then run the hollow threaded rod through here. And then you can even put a nut on the back, put the hollow rod through and glue it into place so it becomes one piece, very, very solid. So that's the plan for that. So the wheel, and then we have to pick the dish size of the wheel. It can be kind of arbitrary, but it has to fit up over the knuckle here. So as long as it fits, as long as it's this diameter, right, or bigger, it'll be fine. And I'm kind of inclined to make it tight, like close to this size, basically, so that there's not a lot of play and not a lot of stuff can get stuck in there. It'll get it scrubbed away by the rest of this. So that actually will be pretty easy. So that would be for the wheel, and I'd want a replaceable tire too. Maybe I'll make solid wheels because it is winter here, and I can just make like paddles or something, and then it'll be decent in the snow, and then I don't have to worry about it too much, but that's the idea. How's it going, Doug? Just showing off the subframe that we designed last time. I printed it too quickly and with shit material, so it kind of snapped, so no good when I tried to run the screws through. So that's okay. We can print it in better material shortly. But there's that. So drive shaft, wheels and tires, another thing we can design today. It would be nice to have the whole rolling assembly. And then the last thing is the frame pieces. P-I-E-C-E-S, frame pieces. So the frame pieces, I'm basically thinking of something that'll interconnect with this, and will be about this size. So I don't want the frame pieces to be bigger than 200 mil by 200 mil, so that people with a standard 3D printer would be able to print them. This subframe, let's see what size it is. This subframe it's actually under 150 mil. It would be nice if I can be under 150 mil by 150 millimeters, so then people with a Prusa Mini can build this RC car. So that'd be pretty nice. But I'm thinking it's going to be sort of like a lattice. Like I like these screws, right? Sort of equidistant. But if we put another screw, right, the piece will become. What's the distance between screws? 6 to 11, 50 mils. Hold on a sec. So right now, the distance between screw holes. Actually, I think there's a trick you can do this. You can grab the diameter of a hole. So let's say should be, let's say 4.6. I'm going to zero that out, and then if you go from hole to hole, so it's 40 mils between holes. So if I go another 40 mils, so this is, it'll be 149. So yeah, if I make it span 4 holes, 1, 2, 3, 4, it should end up more or less 150 mils from end to end, which not that, I think we can do it. We can also try to shrink this down to 35 mils hole to hole. But basically what I'm thinking is the frame piece is going to look something like that. And then all we have to do is like a lattice, right? You take this, sort of like that, and then 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 you just join all these pieces together, and then you can even do like this, and like this, and then like this, and like this, and you just cut out the middles. Take all this away. Oh, that's a good piece. And then you're just left with like a Lego block kind of thing, and then you can just bolt a couple of them together to make the frame as long as you want. And you also make the subframe on the bottom sort of curve up, and so you can make it as wide as you want, because the goal is to mount as many plates as these as you want. You know, something like that. I'm not sure. Also could have battery holders, so it can cut pieces into that. You know, it's all design stuff. So we have those 3 things to design. 1, 2, 3. The drive shaft will be a difficult one to design, honestly. I'm not 100% sure if I'm confident that it's gonna work the way I'm imagining, but here's hoping. Although, you know, you can design the spine, this part separate, and then make a cup separate, and then join the cup with this. That might work too. It's gonna be a tough one. It's gonna be hard to design. I'm not confident in my abilities on this one. But I think if you designed it in halves, if you designed it, cut it in half, printed both halves, glued the 2 halves together, then you get the layer lines going in these odd directions. I think it should hold together. It's going to be interesting either way, but yeah, the frame is something I want to figure out, and the wheels and tires, all these things, so we can actually start getting some structure together and seeing what works, because I don't design well in theory. I need to print out the prototypes and see how they look and see how they work. This is how I work. I work better in the physical. So yeah, I'm much better like taking measurements off and then printing. I am not a master. I wish. But yeah, these things. I was also thinking of modifying the upper control arm to give me a bit more space, but I think that could wait for another day. I also have another issue. My 3D printers need a tune. They really, actually one of them needs to be torn apart completely and rebuilt, and that's going to be a pain in the butt. So I need to get to it as soon as possible, because some of these prints are coming out very bad. Like this one here, you can tell. Come on, focus. You can tell the first layer is so smushed that when I tried to peel away the excess stuff, it broke the first layer. Now, of course, this is some crappy filament, so I did expect some issues with that, but at the same time, I need to fix that. So, yeah, a bit iffy on that, but it is what it is. But we need to design these things so I can actually, you know, sort of get things going. Another thing is I have shocks for this, but I'm so behind on my mailbag videos that I need to film mailbag videos. Pain in the butt. Oh, and if you were here for the design for my, I'm trying to speak into the mic, but the mic is plugged into me. For the design for my boss's gift last week, here's the final result. So this is it here. And so if I take this apart, all right, so there's the box, right? Nice screwed together with the 2 bulbs. I broke this, I cut the details out of it because it was a little bit too much of a pain in the butt to model. So I cut them out and they broke. But other than that, this is it. So let me just give you a little bit of a demo here. So if we grab these, I'm gonna hook these up, 1 and 2. So the nice recessed terminals, I had to move them out. They're not flush, but I think that's okay. They are more secure than if they were like all the way out. And then if I hook this one up to here, so the very first thing you get when you hook up to a source is, you see that light comes on? So that's a 10 milliamp light. So this one is safe to do testing on things like, you know, things that are driven by computer in a car. So this LED, they all have LEDs, but I only hooked up this one because if you hook up the other ones, they're additive. So this would be 10, 20, 30, and 40. And 40 milliamps is starting to push it for some circuits. So just got this one here for 10 milliamps. Then if you want a small load, you got a 1/2 amp load. Then if you need a slightly bigger load, you have another 1/2 amp, so now you're at 1 amp total. And you can even, change it up to go, 2 amps, this one here, and then 2 amps, this one here, but then you can mix and match. So 2 plus 1/2, that's 2.5 amps, and then you've got another 1/2, that's 3 amps, and then you can even go 4 amps, and you can go 4.5, and then 5 amps. So you get the full load. And this does get kind of hot. It doesn't heat the plastic up too bad though, which is good. That's why I left it open, and I also put holes in the top. So even if it's sitting like this, like on the dash, you can flip this on, and the heat should come through this. So yeah, this is, hopefully my boss will like it, but if not, it doesn't matter because it has a utility. So even if he doesn't like it, he'll still find it useful. And then of course you got the 2 probes with the picks to go pick inside of a automotive connector. So yeah, that's that. I can also change these bulbs for orange tinted ones, so they're not as vicious. They don't light up as bright. I appreciate you saying that. I don't feel it because I feel like this is actually kind of simple. It's just packaged nicely. And I also had to fill in the numbers with Sharpie because my printer printed it too shallow and the numbers got washed out. So you can actually see, the surround. It's like, it's all 3D printed in that shape of the numbers, but the numbers didn't stand out enough, so I had to Sharpie them. But yeah, that's the test tool. I'm gonna wrap it today. I brought it to work on Tuesday, and he didn't have a Christmas gift for me then, so I didn't ambush him with it. I will wrap it. I'll gift wrap it today. Either that, or I'll just go get a gift bag because there's no sense of making more trash, right? Wrapping paper kind of causes trash. So one of the two, and then yeah, I'll be able to give it to him tomorrow. So hopefully he likes it. The only thing that I regret is that it's not compact. So he's a mobile tech. He has, he moves his tools around. Doesn't work always in the same workplace. We don't work always in the same workplace. And so it's a little bit big, but if I didn't have this cage around it, I was afraid that, you smash these bulbs with something metal and then they break. And that's not fun, but yeah. This is it, the whole package. Yeah, but I would put it in a box. I don't want to show you the box because my address is on it, but yeah. So that's that. These are crazy glued in, these bulbs, these bulb holders, and they have hot glue to support them while the crazy glue dried. I actually wish I could find, I had the crazy glue out. If I could find it, I want to put a couple extra little dabs through here, but I don't know where it went. It vanished. Yeah. Oh well. So I guess my question is, if let's say like Doug, I know you work in sound. Oh, here it is. If you got a tester, a sound test, let's say a soundboard tester or something that looked like this, would you be thankful, or would you be like, dude, I already know how to do my job. You don't need to get me tools or whatever. I don't know. Just gonna put a little bit of extra CA glue through here. There we go. Just gonna let that set. And now I can put my crazy glue away in the adhesives box. Like the idea for sure. Compact would be better. Yeah, unless it was a shop thing. Yeah, the thing is that to get a 50 watt or whatever 21 watt resistor like that, like a bulb, they don't get much more compact than that. You can get higher wattages for the same size, but you can't get the same wattage for smaller. So there's that. You get a little bit more compact if you use a different kind of bulb, but not very much. Oh, in a backpack. Neat. He's got, just for the effort, yeah, true. He's got a bunch of like these big DeWalt cases that sort of like interlock, which is nice. The thing is his electrical tools box is kind of small, so this one will probably just go in his truck, to be honest. And if he doesn't have space for it, that's fine. I can always throw it in my car too. Alrighty, so I think I might, maybe I will design the drive shaft. We will see. If I can design all this stuff and then, yeah, I'm gonna try. We'll see what happens. I need to design like the splines and stuff. All right, so let's design the drive shaft. I'm avoiding it for a reason, but I think if I get this done, I'll feel a bit better about it. So let's get that done. Oh, you don't like my shop mug? That's all just, it's flavor. It's extra coffee. All right, to the screen we go. This is basically what I was showing you guys. So this is actually the version 1 knuckle. I don't know which version I like better, but there's the version 2 knuckle. The version 2 has these longer steering arms, which we need. There we go. See? The truth comes out. The only issue with this is I kind of want to deal with the little lip inside here so it can print flat like this. Because right now it has to print with this section here touching the bed, because it has a lip that's suspended in the air right there. So this part here can't print if this part here touches the bed. So you can do it with supports though. But whatever, I'll deal with that some other time. For now, we need to design the drive shaft. So we don't have a lot of space here. Let's see if we can measure between here and here. We have 48 millimeters. So let's go 40 millimeters. How big is this? This diameter 25. Okay, so we'll go 40 millimeters. All right, so that should be done in, I don't remember what I called it, the hub? Axle hub. There we go. Axle hub, that's that guy. So I don't know how to space this, so I might just design it on the side and space it out. Maybe I'll just make a new part. No, I'll work in the axle hub. Okay, so plus design. I'll put it on, let's say, this face. Let's see if we can get rid of a lot of the stuff we don't need. Inner spacer, the bearings. don't need the knuckle. There we go. So we're working in here. And we've got maybe 40 mils to work with. Oh, and by the way, this stuff, it could be printed in some fancy materials as well. I'm not a big fan of making it so it needs to be printed in fancy materials, but there are places like, there's a PCB company that sponsors me, PCBWay. And I don't think, so they've got 3D printing. Yeah, so you can get it printed in nylon, PEEK, ABS, PLA, polycarbonate. So the strong stuff would be, ABS would be stronger than PLA, which is what you usually use. PETG is stronger but also flexes more. Oh, you can have it printed in metal. Look at that. Aluminum, stainless, titanium, tool steel. So these things are it's possible that they get printed in fancy materials, but I don't want it necessary to be printed in fancy materials. In fact, I have PETG here, which I plan on building my final stuff in. But I have to upgrade my printer a little bit, since the high heat needed to print in PETG, which is not even that hot. Like polycarbonate is hotter, and nylon's even hotter, or vice versa. They can degrade the one of the materials on the hot end, so I need to upgrade it. But yeah, so this stuff, I mean, I design it so that PLA is doable, but it's not necessary. Okay, so the deal here, how am I going to design this? So I need to cut splines. I don't know if you guys remember splined joint. Not like that at all. Go like a CV joint. Yeah, except that has bearings. Let's go. Yeah, sort of like this. Okay, so there, and then the splines would be like a ball. So that would fit inside there. The best thing is universal joint socket spline, pinless. Don't know if there's actually a really good view of it, but yeah, like that. Someone needs to take one apart so I can show you guys what I mean. You should get a laptop. I mean, it's possible. Laptops are kind of expensive though. Although like Framework, my next, you know what? You can use my laptop. It's in the kitchen. So Framework laptop, which will be my next laptop. You can, there we go, Framework laptop. So you can actually replace every single part of these laptops. So absolutely everything is available. And in fact, if you have their old, this is a design number 2. If you have their first design, they have a kit to turn it into a desktop computer. So you can upgrade your laptop and have your old internals turn into a desktop. So yeah, just, it's expensive, but it is Canadian dollars. You can replace everything, which is nice. Thinking in the near future. Okay. But at any time you can use my laptop. What kind of stuff do you need to do? If it's just like word processing stuff, you can use. I can set up a Raspberry Pi for you. Write or draw. Yeah, write is okay. Draw is a pain in the butt. Like custom. Yeah, I love the customizability of that too. Because yeah, you don't have ports on the side. You buy these port adapters and they just plug right in. And the cool thing is they give you the engineering drawings, so you can actually make your own. Yeah, so the base, yeah, get an i5. So it's pretty neat. How's it going, Adam? It's not that easy, Franco, because the cooling solutions are very custom. So if you go here, let's go back home. DIY edition, that's okay. There, so this is the upgrade kit to upgrade your old one to the new one. What's the? But yeah, there's a box they sell you. But yeah, look, you can get every single part of it, which is really cool. Buy a pencil and paper. Yeah. The problem is that like not everything is easy to do, and on top of that, like if you're trying to be productive, and you're typing like a story or whatever, you can write a story on pen and paper, but then you still have to go through the effort of writing it out after at your PC. It's kind of a pain in the ass. The other option is a Chromebook, but I don't know if you can draw particularly well in a Chromebook. And the problem with a Chromebook is if it fails, like you can't repair it, right? Because it's all like integrated. Oh look, it shows my address. Just kidding. That's the this is the address for the PO box. Chromebook. So yeah, like 200, let's say 250 bucks. But like you really get a kind of a junk laptop for that, to be honest. 4 gigs of RAM. I mean, it's basically like it's like a shitty tablet with the keyboard. I do get that the you know, the battery lasts longer and whatever, but it's just not a good deal. But you can draw and stuff, because I know there are like the drawing tablet I got works on Android. I have the adapters down here. There we go. The old 212 to 2014 MacBook Pros is best for this. Could be modified repairs, but the new MacBook Pros are just crap. Yeah. You know what I would like? I would actually like a MacBook Air, because the battery lasts like 4 days. But the issue is that if it fails, you're out like $2,000. Like, yeah. So you're out to $1,200, and honestly, it's not a very like you can build a PC for $1,200 that will blow the snot out of this thing. And this is a 2020. This is an old one. So that's like a refurb or something, right? Yeah, $1,500. Like, we can easily build a PC much faster than this for less than this. So it's like, it's all BS, man. Oh well, it is what it is. All right, back to work. All right, so we want a roughly, can we get the center of this? Yeah. So let's go like 40 mils being our like full maximum. Wow. For album artwork on Amiga emulator. You are nuts, my friend. I kind of want to offset this up though. So if we have a 40 millimeter sphere, that means 20 millimeters up is the exact center. Right, so can we take this and actually move copy? And I don't want to move it up 20, but maybe 15. What is going on? Oh, what? Move copy. I want this whole thing. Move copy. Oh boy. This is not working out. On this plane. That one. Why are you rotating? Okay. Let's try this again. 13-inch 2012 MacBook Pro still works this day. One issue, Apple stopped supporting Intel MacBook Pros. I also have the circuit diagrams. Yeah, you could. Well, let's be honest. Repairing it is not an easy thing to do, though. It's like totally not an easy thing to do. All right. Want the middle of this. There. All right. Now I'm going to go up on this plane. And I want it not 20 mils. Let's go 15 mils. All right, so there. And now I'm going to make a circle here on this plane. Oh, that's not what I wanted to do. Let's look at the bottom. Circle on this plane, that'll be 40. Kind of independent. No, it didn't do it at the right spot. Circle on this plane. $40. Is that exactly on the right plane? It is on the right plane. Okay, that's good. Now, so that's a 40 mil diameter. So if we make a 35 mil diameter circle, that means our circle walls are going to be guaranteed to be 5 millimeters. Hopefully that's going to be enough. Okay, so that's good. So that'll be like kind of the outer wall. This will be the inner wall. And now we need to design a spline system. That's going to be the tough part. I'm not quite sure how to do this, but we're going to figure it out. We're going to figure it out. All right, let's divide our circle. I think 4 splines makes sense to me. So we'll go up 180 degrees. Yeah. Oh boy, computer didn't like that. All right. Still on that plane. Yeah, I'm still on that plane. Okay, I'm going to take this, go across. Like so. Turn that to a construction line. Use the halfway line, can delete that. That's good. Okay, and then $90 degrees exactly. Take this and drop it this way. 90 degrees exactly. That's good. Take that half line. All right. So now how big do we need our splines? That's the question. So I think it needs to be chunky enough in both senses. So let's grab this line and we're gonna offset it. That is offset, right? It's only curves. Okay, that's weird. Okay, fine. We can deal with that. What kind of rectangle can we make? Fine. You want to be like that? Oops, I did not mean to do that. Edit the sketch. Why are you not? Oh, I'm still in the sketch. Okay, we're good. All right, so let's kind of see what that looks like. If I grab this line here, 8 mils. Let's go 8 mils. Jeez, this is difficult. It like doesn't want me to take this. There we go. Okay, 4 here. And then another 4 here. And then you do the same thing here. 4 here. And then 4 here. Hey, didn't I say 4? There. Okay. So let's slice this now. Take that. And then let's make a rectangle. Come on, let me select this frickin' point. Why you gotta be like this? This is not cooperating. This. Let me grab that. You know what? Actually, the length doesn't matter. Okay, like so. And like so. All right, so this should be our interior splines. Now I can just take this and sort of, oh, what's going on? Oh my God. It's not even on the right plane. Oh my God. Can I just move these? Move, copy. Yes, okay. -15. There we go. It's just having so many issues working in 3D here. All right, now can I snip these? I can. Okay, just all go away. No, that's not what I want to snip. No, no. There we go, snip that big one. Okay, go away. Go away. What's going on here? Snip this guy. Yeah, okay. Snip this guy. And this guy. This guy, and this guy. This guy, and this guy. So you see how I have like that that cross shape in the middle. Can even snip these guys. Go away. Go away. So that is the positive spline. So this is going to be like part of my drive shaft, and these holes are going to be part of the drive cup. I don't know if that makes any sense, but don't worry about it yet. These can delete. Don't need that. Don't need that. Don't need that. Okay, so even if I get rid of this guy, so now it should be a little bit more obvious. Get rid of these ball joints too. Yeah. Trust me, bro. So, yeah, that's going to be... So now the issue is this needs to be a sphere. That's where the hard part comes in. This needs to be a sphere. I need to like cut this into a sphere. I don't know how that's going to work. But anyways, this inside piece, that needs to be cut in out of a sphere, into a sphere. This needs to be cut out of a sphere. So let me just see what happens here. Let's bring back the body. Bring back the sketch. Oh. Okay, now if I create a sphere at this point, like very specifically this, let me put it there. This, I want to put a sphere here. Oh my God. Please send help. There. All right, 40 millimeter sphere. It's going to say, it's going to want to cut. I don't want to cut. I want to join. What is going on? No. Create sphere. Like right here. Right here. I have a feeling this is looking through this, not at this. No, it's at this. So right here, the intersection. Why? Why are you doing this? Why are you not letting me? Oh no, look, it's looking through my sketch. That's why, that's the issue here. Okay. If I select this point on the sketch, and then I go create sphere, does it do it there? No. Oh my God. Can I go to the bottom point? I can go to the bottom point. So there. Point. Plane. Right here. Right here. I can just grow it as big as I want. Oh. Something happened there. Why? Why do you forsake me, software? What have I done? There. There. Oh my god, I think I got it. No. It couldn't be any further. Please. Let me do this. Here. Okay, I have an idea. I have an idea. Take this, extrude 0.1 millimeters. I show the sketch again. I want my sphere. Create a sphere. Oh, now you're cooperating. Right here. No. What? Why? I don't know why this is so difficult. Here. This. Bodies. Here. Create. Yeah, it's miles away. Yeah, I see that. Insert. It's gotta be like an offset plane. Offset plane. 0 mil. There. Oh, okay. Can I edit this? Properties. Offset plane. 15 mils. Plane 1. Delete. Okay. Plane 2 is there now. Now I can I make a sphere? All of a sudden I feel like I can make a sphere. The fact that it's not lining up tells me it's not actually seeing it. It's not. Oh no. I forget which way I have to zoom. Okay, this way. Yeah, still not doing it on that plane. Plane 2. So I have an offset plane, and it's still not doing it. Do I have to extrude my own sphere? Oh, I am on this plane now. Don't know what happened there, but okay. I want to join. This is it. This is what I wanted to do. All right, I just don't know if I'm going to regret this at all. That should be fine. All right. I want to take this. I want to slice it. Do I show this? So take this, right? Modify. I want to split it. Splitting tool, this face. Okay. Take. Oh no. All right, let me try this again. Split body. This one. Splitting tool. Okay. There we go. So I could take this one here, and I can delete this, right? Dang it. No, it... MicroPython? Are you listening to the podcast? Is that what's going on? Python? MicroPython? Oh. These are different. What's this? Oh no, it's just different face. Okay. Split body. This body. Using this. Okay. All right, so then we've got two pieces. Move copy. Okay, it's not in the way anymore. Okay, so now, so far so good. Can I just, what happens if I delete this now? Okay, it's gone. Oh, I see. Well, you've come to the wrong place because I know nothing about coding. My wife might be able to help. Vero, we need some coding help. Okay, so sphere, right in the middle. No. Don't you frickin' dare do this again. Sphere. Okay, I'm on this plane. There we go. 35. I mean, I feel like you have the capabilities of figuring it out, though. Okay, okay. I think we're getting it here. I need to get these into the cup. This, 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 and this. So what happens if I extrude these down, like let's say 1/2 mil? Oh, that's not what I wanted to do. This, 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 and this. Now extrude this down with a join. Okay, I've got this. I gotta grab the bottom faces of these things. Is there an angle at which I can see the bottom? Let me see the bottom. Hey, Johnny. Hey, Johnny, you're a coder, right? Adam Bryant says he can't figure something out. So you're a shoo-in. Also, do you guys know it's like 3 days till Christmas? Okay, how do I make it so I can see inside here? I guess what I can do is I can bring back whatever sketches I had used. That would be the wrong sketch. This one. Take this, extrude upwards, cut all this stuff out. Okay. This, extrude downwards, cut all this stuff out. So I got some vision now. Cut some of this stuff down. Don't remember how far down it needed to go. to there. Should do. All right. So now we got some cuts going here. That's good. Oh, wireframe. Yeah, that might work. We're designing the axle hub. So this will actually, like your drive shaft will go inside here. You can also just do this. You can sneak in there. Get that face there. 1, 2, 3, 4. There we go. All right, now the press pull feature should be able to figure that out. Let's see. Right, press pull? No, press pull. Oh my god, and I have to select them again. Well, I guess I'll figure out what happens to one of them. Oh, baby. Oh, no, don't go through. Why you go through? I don't want it through. Yeah, like a cardan joint. For sure. But why does it go through? I don't want it to go through. I want it to be inside there. I almost feel like I should, I feel like I'm doing this backwards. I feel like this should be a solid sphere. I need to design the splines and then cut the splines out of it. You know what I mean? Hold on a sec. Just, dang it. So hold on. We got some drama here. My boss is asking if I want the day off tomorrow. I'll say I don't mind the day off at all. Well, that sucks. I didn't give him his gift yet. Oh well. Well. All right, you know what I'm gonna do? I'm gonna abandon this. I'm gonna leave this like this. I'm gonna design the positive side, and then I'll put them together and I'll cut it. I'll chop it after. I'll cut the positive side out of this. Now the question is, how do I make the positive side? Only work 2 days a week. Interesting. Yeah, the thing. So the thing with me is that if as long as I'm able to pay my bills, I really would rather work less than more. So when he's asking me if I want the day off tomorrow, I'm already inclined to say yes. So, you know, I have to work Saturday at my last shift at my current job, not with the cool boss. So that'll be interesting. Okay, so what I'm gonna do here is I need a 35 mil sphere, and I can cut these out of the 35 mil sphere. All right, so I'll grab a sphere. I'll hide, first of all, I'll hide this body, and I'll craft a sphere on this, sure, on this plane. Oh, I swear to God, if this is not on the right plane, it's not on the right plane. Craft a sphere on this plane. All right, 35 mil sphere. So that's it there. New body, that's fine. All right, good. Now I need to grab these, 3, 4. Yeah, okay. And this for good measure. And then I'll take this body back like that, and I'll extrude. I'll chop that up like this, and I'll actually drop it offset. It'll be negative, I don't know, 20. There we go. Okay. So there is, that was a lot easier to create. And so now if I bring this guy back in, if you see, I just need to cut this shape out of here. Does that make sense? Next gig is the second week of January. I'm already dreading it a little, but then my desire for income should balance it out. Yeah. Yeah. The need for income. That's the shitty part, isn't it? That's the rub. That's the part we have to suffer with. Stupid capitalist systems. Now if I take this part, this guy here, this body, and if I go like cut, combine, okay, target body, tool body, this one, operation cut, and then keep tool. Okay, what did I get? What did I get? Hey, I said keep tool. Why? Why did this no work? Let's try that again. So this body, combine. Oh, not new component. Tool body, this one. Keep the tool though. A copy of each tool body. There, that worked. Yeah, Vero, I wish I could be of more help. Okay, grab these faces. And I need to make some clearance. Press pull them. Negative 0.2. 0.2. I'm going to go negative 0.2, and I'm going to round these corners so they're not so sharp, which is probably useless because I still need to run the bolt. Fillet. Probably something like this. So you see how that fits in there now? I can also round these corners too. Then fillet outwards. 4 mils. Sort of like that. Chrome is probably just using way too much memory, I'm assuming. I'm gonna have to stop using Chrome pretty soon. All right, get rid of this. Now, if I can bring back those sketches, sketch 2, grab this, extrude all the way through. So that's cut neatly. And then bring back that sketch, this guy, and then we need to extrude upwards, cut that out. Take this and extrude. Let's say 7 mils in. Get rid of that. I think that should work just fine. Affect Safari as well. Oh, interesting. Just need to fix these weird artifacts inside here. That is from... Oh, I think this is tiny. I think this is just... Yeah, that's weird. I'm gonna press pull. Oh, no, I need to grab all those sides. So I think this is actually an artifact from the fact that I grew the bolt hole a little bit because the bolt was too big. Like that. If I press pull that. Yeah, that looks like clearance. 2, 5. There we go. And then I think that's good. So I just need to round over these holes. And then I think I'm good. I could probably leave the sharp edges there. It should be okay. I'm curious if this is going to work as is. It looks pretty damn cool. I'll say that. Might have to print it on its face. I don't know how to print this. My plan originally was to slice this in half and glue the two halves together, but I don't know if I'll do that. What's going on here? Oh, I need to extrude this face out now to cut deeper. Extrude. There we go. That should do it. Now it's all even. So the bolt sits in here, and then this is the axle part that'll go in there. And then basically I can just make a sketch, create a cylinder. Yeah, I'm gonna see what it looks like with the supports. Maybe it won't be so bad, but we're gonna see. Maybe the joint will work, maybe it won't. Only one way to find out. Reboot. Anybody here watch Reboot when they were a kid? So that should work. Now I do want a hex shaft to be part of this. Question is it okay being like 8 mils wide? Do you think it'll just break apart? Yeah, the cartoon. Well, the CG graphics thing. You know what? I actually will have to go to the bathroom. I will be right back. I don't have a be right back screen. But what I'll do is I will mute my mic. And I'm back. Yeah, I just went to the bathroom. As the British would say, I went for a slash. Is that what they say? I think that's what they say. Oh, interesting. So you like mute them as they walk off? All right, another sketch here. You can't exactly make a sketch on top of this, no, can you? Guess I'll make an offset plane instead. Oh, and as for the comment, can I make it angled? I could, but before I make any sort of printability things, I like to see if it prints, because it might just be a pain in the butt, or if there's a design issue. So first I want to get the rough thing down, and then I'll work on perfecting it. I'm not exactly an expert, and so I just have to do things one thing at a time. All right, so I'll take this offset plane, create a sketch on top of it, like so. Okay, so it can be circular because it needs to drive, so it needs to be hexagonal or square. I could make it square. I like hexagonal better. Hexagonal polygon. Okay, so where's the very center? I'm not getting any more centered marks, huh? The software won't let me find the very center. Why I did this off center, I have no idea. Don't ask me. What if we bring back this sketch? Can I find the center there? Oh. Yeah, there it is. All right. So, how big of a hex is acceptable? This will be on the inside, by the way. So I guess 8. Yeah, I guess an 8mm inside hex. Like so. Whoops. Oh well. Hopefully, did you ask them if they liked what they heard? I need to kind of grab as much material as I can, maybe like there. Join, offset, -5. And then we'll go maybe 20mm, like so, something like that. There we go. Now we can grab these things and fillet them. Filet o fish. I wish I could just tell it to just be smooth. You know what I mean? Like say, look, I got this curve and I got this curve. Can you just give me the difference between the two? You know what I mean? Like if I could just tell it to blend together, like smush together. Like I know I can fillet these two in, but like that doesn't really accomplish what I'm looking for. Maybe if I just grab this and I press pulled it. Nope, it does nothing. Does anybody know how to do that? How to just like tell it to just mash itself down? Or maybe I should just like cut this out of that. I don't know. So like a smooth. Remove faces. Let's see. This one. Just delete that whole thing. Maybe if I just grab this corner and fillet that. I mean, that's good enough, right? kind of like this filleting more though. This, and this, and then just fillet those. Yes, stupid. 2, 3, 4, and then fillet. It's going to look ugly, but I think it's going to look ugly no matter how I do it. Oh, that's not good. So what's everyone doing for Christmas? My dad's got COVID. Actually, both my parents have COVID now. So that's fantastic. They're old and stubborn though, so I think they'll be okay. Driving up to your sister's place? Are you driving up there to drive her nuts, or what's the deal? Maybe I'll just go for a chamfering operation. I think the chamfer looks the best. I'm just gonna chamfer it. Go to distance. Make it as smooth as possible. There we go. That's good enough. They decided on boosters. 65 plus 1 booster per year, 85 plus 2 boosters per year. We actually have to go get our... I think we got boosted once. We need to go get another booster. I think my parents also... Oh yeah, my parents didn't get the other booster, so there are 3 vaccines in. So there we go. This is a part. Now we can make the outer housing. And yeah, that should work together. Hopefully I can print these 2 parts and then see if they interface together. Plan to get your booster next week. Your next booster, I guess? Or your first booster? What's the deal? Hopefully this joint will work. Number 4. Yeah, okay, so we're going to be on the same amount. Oh, look at that. My podcast guest commented on her podcast appearance. That's always good. If you guys haven't seen it yet, Senya is the latest podcast guest. She is an actual wizard. Oh. I think... Vero, I don't know if you're still in here, but you know how our Christmas gifts were supposed to come in on the 27th? Well, they're coming in on the 24th, I think. Thank you, I appreciate that, Doug and Franco. So is all this material actually necessary now? You know what, I'll just leave it. That's fine. can delete this. I think it looks pretty good. Maybe I need to make this a bit bigger though. Extrude up. 15, there we go. So that'll fit inside of another piece. I haven't heard about her. Well, she's not a public figure, but her Instagram is pretty freaking awesome. Oh, not available. Is that her thingy? Give me a second. Well, regardless, she's a really cool person. So there's that. Instagram. Nope. I'm not going to turn on knit to code. Oh, there's no at. Idiot. And then back to here. And I'll switch you guys back so you can see. Screen. And I need to get back my streaming. There we go. And this is her. So this is her. And this is one of the projects she's done, which is a blouse that has light up LED flowers on it. So that is pretty cool. She basically does sewing, knitting, and electronics. There's the blouse. Oh, no, come on. Do I actually have... I need to log in? No, there we go. Look at that. Looks so good. Can't open image in new tab. So yeah, it looks like if you think of like how much it would cost to get someone to build you one of these, it's like thousands of dollars. Like, look at that. Yeah, she is very intelligent, of course. So yeah, she has a few wearable projects. Go away. Block element. This one. This whole thing. Create. Yeah, if you want me to make you one of those, I'll just have to check how much Senya would charge me, and then I'll have her make you one and send it, because she's a Finn, so she's right next door to you. So her shipping it to you won't cost all that much. So I don't know. I'll bet you she'll do it for 100 grand. But yeah, there's like, and if you're being serious, if you want me to make you custom stuff, I can definitely make you custom stuff, but it won't be cheap, because people deserve to get paid for their stuff. You know what I mean? All right. So yeah. So this is done. So now I don't want to continue this. I don't want to continue the other piece until I see if this works. Basically, because if I have to go back to the drawing board, I'd rather do that first. So that's done. So let's move on to the this one. Let's move on to the wheel. There's the bearings, spacers, and then where's the knuckle? There's the ball joints. The control arms, the subframe. Look at that, it's going right through the hole. And I've lost the knuckle. Knuckle? Oh, there. There we go. So that should work pretty well. I can actually back this up a little bit. I know how to I know how to sew a little bit. So there's that. All right. So next we want the wheel. So let's make another component. New component. Type standard, name wheel. Okay, and then let's make a new sketch. Create sketch. We'll go on this face here. All right. So, first of all, what's the size of this from here to here? So that's 17 mils exactly. I think I want to shrink this. I don't want that to be exactly 17 mils. I want the wheel to be 17 mils. And the reason for that is I believe that's the size of hex that's inside the wheels. Okay, I need to head into the other room to go grab a wheel because I want to measure what size a standard wheel is. So you guys just stay entertained looking over here because I'm not going to bring you with me. But you should be able to hear me all the way through. Hearing the furnace. Oh, one of my wires got tangled. Okay, light is on. Now the big question is, will I be able to find a 17 millimeter socket to get these wheels off? That's a big question. I don't have metric wrenches down here either, so a wrench won't help. There we go. How am I going to do this? Husqvarna sewing machine, interesting. They do, they mostly just do you know, yard work stuff, right? Like chainsaws and stuff like that. Oh man, maybe I do have a 17 mil. Oh, made something fall. That's okay. It's only a really expensive meter I don't know how to use. 17, right there. Nice. Yeah, they sold it off, renamed it to Viking Sewing Machines. Interesting. Yeah, I have a sewing machine here too. I bought it at a thrift store. I've used it once or twice. I need to do some more. There we go. Yes, I'll be able to do this. All right. So I want to measure the hex of a standard wheel because, again, people who don't want to print their own should be able to just buy commercial stuff if they would like. So this is a this is from a Traxxas Revo. These wheels cost me an arm and a leg, and I tore the tire on one of them on the first outing, so that was fantastic. Oh, neat. So the outside nut is the same size as the inside, so I can just measure this. Perfecto. Are you fucking kidding me? No, okay. They are 17 mil hexes. So actually the hex is 17 mils. And so the wheel is a little bit bigger than 17 mils. Or is this 16.96 and the wheel is exactly 17? Don't know. But regardless, it looks like if, oh well hell, where is mine? I could just take mine and slide it in there. Over here. So what size is this? So this is actually a little bit oversized, 17.12. So that will not fit. Nope. So yeah, I do need to shrink that. So I'm going to make my wheels exactly 17 then. And then I will shrink this a little bit before I print it, print the new version. All right. Oh, Husqvarna is, or Husqvarna is actually a place. I did not know that. Okay, take the V2 axle hub. Just gonna finish the sketch. Grab the V2 axle hub here. If I activate this component, grab these, and I'll shrink them by 0.1. Press pull, negative 0.1. Seems to be a, okay, 0.05. There we go. Husmil? You say Husmil. Is that what it says? Husmil? Or Housemill? Housemill. Wheel. Let's activate that component. And let's grab my sketch again. Okay, so we definitely need a 17 mil hex, which this is already. That's the negative. What do we want to do here? So we want a circle that's bigger than that. Center point. So let's go, let's say like 25. That should be big enough for the hub. Sketch, grab this and pull it up 5 mils. It should really go this way. It's actually going to go more. Go nearly 10 mils. So 9 mils that way. And then pull this out. Extrude. Let's say about 2 mils of depth. Oops. And then take this up 2 mils as well. Oh, they're not the same size. Uh-huh. Let's see if we can fix that. How's it going, Big Z? You can call me Dan, by the way. You can call me Electronics if you want, but you can also call me Dan. You call me whatever you want as long as you don't call me late for dinner. Ha 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 ha. Bearing spacer. Can get rid of the axle hub. Need to grab sort of this area. I bring the sketch back. Oh, I grabbed the wrong part to extrude. Extrude. up to there, join. There we go. Very droll. Nice. Okay, so how much space do I have? I do want to kind of offset this a bit. Oh, what's going on here? Oh, that's the sketch. Yeah, okay, this is good. So how wide do I want this tire? It's winter time here, so quite wide to start with. Okay. I do need it to be flat though. All right, so let's extrude up. Yeah. Let's say 10 mils. I'll deal with this after. All right, now how big can I go? Go quite big. Let's go another sketch using this. Make a circle, center circle. Let's go 90 mil interior. And then 95 mil in exterior. Sort of like that. Okay, grab this face. Finish the sketch. Grab this face, extrude it down. $5 face, like that. Bring the sketch back. Take this one there. Extrude down. See if I can go right up to the edge. Maybe a little bit further. 62 mil wide wheels. Let's see. That's not very wide. Oh, 65. So that's not extreme by any means. But there also is the possibility of the inner and the outer rim being printed separate, or the tire overlapping. Because like you can just stretch this out more, but I like the idea of flat, like so. Okay, I might need to actually cut, like extrude this down a bit as well. To allow everything to fit, sort of like that. 3-piece rim, I have considered it. I am just thinking simplicity first. 3-piece rim is definitely possible. And by 3-piece, you mean inner hub, dish, and outer rim, right? That's what you mean? Okay. So I think this looks good for basic setup here. I think that looks all right. And then I can design a tire that goes over top and can print it out of, print the tire out of the, flexible stuff. What am I thinking here? TPU. Could angle this too. Let's see. Chamfer, single distance. Oh, too complex to blend, maybe too big. Should go down to 5. No, it's one of those things you gotta go 4.99. Yeah, there we go. Oh, actually that might make it really thin, depending on the hub. So I can just grab the hub here and do the same thing. Chamfer. Whoops, grabbed the wrong edge there. I need to get rid of all these things. Go away. Oh yeah, no, that's why it doesn't work. It can't do it because it's the thickness. But I can do a chamfer here. Chamfer. Oh, I think we're at the point where these two are not. So I think, yeah, these two are meeting. They're not actually connected to anything. So I do have to keep this like this. I can make a smaller indent, or I can make this part bigger. Can do that like that. All right, Franco, thanks for coming, and Merry Christmas to you too. Happy holidays, or whatever you celebrate. Extrude. Five. Get rid of the sketch, and then let's chamfer that. And now a 5mm chamfer works. There we go. Cool. And then we can rotate this and we can make a cool design. So if we do a sketch, and we grab this, and then we decide to polygon, doesn't really matter, one or the other. Go in the middle, and we choose the sides. Let's go 5, and then I don't know, somewhere in between here. Sure, 25, like so. Oh, Vero, you're here again. The stuff that was supposed to arrive on the 27th, it looks like it might be arriving on the 24th. Now there's a way to make a pattern. Circular pattern. Center point. There. 5. There we go. And we can extrude. Oh, finish the sketch. Grab these. Oh. Grab these. And extrude. Did I actually make that disc 5 mils thick? Ah, whatever. I can make it thinner. Oh, that didn't like that. Well, I mean, that's just what I'm just, that's what Amazon said. Who knows if that's actually true? Let's actually press pull this a little bit. And then see if we can actually take this down. Just to like so. There we go, that should be good enough. Let's see if we can grab this edge and do a little bit of a fillet. Six mil fillet, that should do. Grab this guy over here, do the same thing. Fillet. And if we get rid of all this stuff out of the way, go away, go away. And honestly, that doesn't have to be that big, so we can take this and chamfer it down. Probably going to do a 2 distance chamfer. You know what? I'm going to delete this fillet. I'm just going to do a 2 distance chamfer on here. So in to there, and then down to there. There, that should be a nice reasonable wheel. It looks like I'm not working tomorrow at all. Which I'm down with, because that means I have tomorrow off, and that also means I have only work on Saturday, basically. I'll have to give it to him after. That was a risk. That was definitely one of the risks, and it happened. The alternative would be like telling him, no, I do want to work, but then well, then he has to work. There we go. That should be a decent wheel. How could I wish I could afford to go to the party at the NP penthouse, but I don't smoke and guests are required to bring cigarettes to put in the ducting. I have no idea what you're talking about. But I do know that not smoking is a good thing, so good for you. I think that's a reasonable looking wheel. Do I need features on this wheel to make sure the tire doesn't slip? Probably should. I think the tire will have to be glued on anyways. Oh, Nakatomi Plaza. Oh, gotcha, gotcha. Okay. So let's... Oh, that's not how it's supposed to go. There we go. Looks prettier like that. So let's make splines on this to hold the tire in place. So I need to make a new sketch on the face, and I'm going to make a 2-point rectangle. Actually, I need a center line first. Okay. And let's say only need a couple mils, like say 3 mils. Line here, 3 mils like so. Could be another construction line. Don't need this anymore. And then like maybe 3 mils again. So 1.5 this way. And then I can grab this and go 3 mils. And grab the small one, and that can go away. This can be construction line. Okay. Grab this, go to there, and go like that. We can snip the excess off. You're gone, you're gone, you're gone. There we go. And now we can make a circular pattern. Objects are 1, 2, and 3. Center point, the center point. Let's go 6 of these. 1, 2, 3, 4, 5, 6. That's good. Okay, that's good. I'm getting actually pretty hungry, so maybe another hour until 4 p.m. How's that sound? Do you need me to take longer? I could take longer if you need it. Right, extrude. $65 mils, that's good. Okay, and now I want to if I take longer, he'll just slack off more. Okay, let's not slack off then. What's funny is because these things have these paddles to hold the tires, it'll actually be reasonable to just run these in snow. Okay, so that's that. Now I can do a chamfer. We'll go equal distance, 3 mils. So there we go. So that'll actually hold the tire on. The tire will be able to slip over this edge. Yeah, thumbs up if you want to. Absolutely. I like this group because it's the dedicated few. Uh-oh. Winter storm warning. 15 centimeters tonight. With another 5 to 10 on Friday afternoon into Saturday. Wind chill values approaching -20. Okay, that kind of sucks. Okay, but I guess I didn't know how much snow was falling. You know what I mean? Got one lined here. So I think that's a decent looking wheel. Flash a NeoPixel and ESP32 Pico D4. Aren't you in Georgia, Doug? What's cool and damp? What's your definition? That's all good. All right. So I guess the next thing we can start is the tire. Should work, Adam. .40 F. Okay, 440 Fahrenheit. Let's see. 40 F to C. Oh yeah, 4 degrees Celsius in Georgia. That seems like it's gonna be really cold. Like 4 Celsius, I'd be really happy with here, but we're used to it. For someone who's not used to the cold, that actually feels quite cold. So you have a good coat on, I'm assuming, when you go out. Yeah. Yeah, you know, I really don't like when some people try to say like, oh, where I live, that's really warm or whatever, but it's like, it depends on if you're used to it or not. Like, I hate when people do pain Olympics, if you know what I mean. Like, they try to say like their cold is colder than your cold, when it's all about context. Okay, so now if I just design, so if I go new component, tire 1. It's 100% relative. Yep. You're completely correct in that. Yeah, I'm with you, bro. I agree. Okay, so tire 1. Okay, and make a new sketch. And we're going to take this wheel. And we want to start the tire the size of the wheel. So I'm not going to give it an interference angle. I'm not going to give it any play, sort of like the tire being slightly bigger so it slides on, because TPU should stretch, and I want it to be a tight fit. So that's what I'm going to do. And then we want another thing, let's say, let's go like 100 115. So like this. All right, so finish the sketch. Let's take this and we'll just extrude it. 65. Like so. And then we're going to take this and cut it with the other thing. Take this, right? This whole thing. And combine. Target body is this. The tool body is going to be this. Keep tools. Hopefully that works. And then if I hide the wheel, there we go. We've got an exact cut now. I do need to stretch this out though. I'm going to extrude this 1 mil higher. So the tire is actually going to be a little bit bigger. Extrude 1 mil. There we go. So it'll be a bit bigger. And that should lock in quite nicely. There we go. Or when people downplay things, like to say my back is hurting a lot, everyone says, oh yeah, mine too, everyone's back hurts. Yeah, there's a difference between a sore back and frickin' Vero's medical condition. Literally has a medical condition, folks. Chamfer, we're gonna get a little bit of chamfer like so, not too much. And I'm gonna leave this one sharp. All right, now we need to make a pattern. And so let's align ourselves. Create a sketch on here. And do but I slipped a disc and trapped the sciatic nerve when I was 18. That day I learned about paralyzing pain. Yeah, I mean, dude, back pain sucks. It's horrible. And yeah, it is very frustrating that people minimize. They say that your back pain's not real back pain or whatever the hell they say. What's 115 by oh wait, you could just do 115 divided by 2. Yeah, okay, so that's good. 15 divided by 2 plus, gonna go like 3mm grooves. That's good. And then I feel like making circles probably easier than dots here. So let's go 3mm diameter circle, and then I can make a rectangle sort of like this. I could actually just make that 3 mils, like so. There we go. Okay, so grab this guy and make a circular pattern. Circular pattern, center point here, and let's go 20. Does 20 look good for tread, or do we need more? Has to be an even number. 24, 28. I think 28 looks better. Okay, so let's do why not 30? We'll do 30. 30, okay. Now we can grab every, oh, we can finish the sketch. One, grab every second one. Oh no, what have I done? Made a mistake somewhere. So with 30, I should be able to grab 15 of these. What have I done? Did I miss one? What do I have? 2? Guys, am I an idiot? I mean, seriously. Oh, I am an idiot right there. Jeez. All right, so now we extrude these 15 faces, and it's 62 millimeters from one end to the other, I think, right? 65? 67 millimeters. So what's half of 67? Divided by 2. 33 and a half. It's actually half of 65 I want. No, wait. Okay, wait, hold on. All right, bro. So 65 divided by 3 times 2. Let's go 43. Okay, so negative 43. Okay. Join. So there's that. It's not interfering with anything, right? Okay, start. Offset. Negative 2. Like so. Yes. I believe this is what I want. Okay. So the idea here will be to grab these guys. and then chamfer them. Chamfer. Well, it's not going to be fantastic for edge grip though. Okay, maybe I'll cancel that. Maybe I'll cancel that as well. Maybe I'll try something else. Let's grab every second one again. Oh, but they're not full rectangles though. Okay. Okay. I know what I'm gonna do. I'm gonna get rid of that chamfer. I think I'm gonna just leave it square edged. Oh, this is how you make mistakes. All right, let's try this again. Let's extrude. Do want to go about 2/3 of the way. Actually, even 50 mils is fine. Do that. Join. So that'll be good. Then I'll just chamfer these. What happens if I just chamfer the entire outside edge? Like if I take this and just chamfer that, what does that do? Can only do 1 mil of chamfer. Okay, it's fine. Thanks everyone who's watching paint dry, basically. This can't be very entertaining. So hopefully you've got something entertaining going on your second screen, or you're working or whatever. That's not what I wanted to do. I have to click everything all over again. You know what? This. Can I just do this after? No. Applebrook video adapter. Oh, it's Big Z. It's just something I do. You're just gonna have to get used to it. I do it when you guys aren't around either. But it is like repetitive tasks, right? It's not like I'm not like singing and dancing or anything for you guys. Chamfer. Let's go. There we go. So like this, and then I'll chamfer the other edges as well. Rather watch paint than football. I'm boycotting football, and by football I mean soccer. I don't believe Qatar should have hosted the World Cup. So I'm boycotting it. Now, I wasn't going to watch anyways. But that's not the point. The point is, Qatar should have really never hosted the World Cup. Okay, chamfer. Like so. All right, so that's half of our things. Now we need to bring the sketch back. That's not the sketch we need at all. That's not the sketch we need at all. This guy. Now you have a reason. It's a case of money talks. Oh, it's definitely money. But you know what though? I'm not big on any sports really. I watch motorsports sometimes, but again, not often. All right, so negative 50 mils. But now we want to offset. And we want to grab that offset to be, so it's 67 across. So is that, what, 17? Negative 17. Let me do a join operation. Like so. And then that should be it. Get rid of this. Then I gotta chamfer all these edges. I should probably get a 3D print started because it's freezing in here. Elon Musk was in Qatar. Yeah, actually, Musk's appearance there is actually much more sinister than that because he took a selfie with one of the leading Russian propagandists over there. And we all know how he's been praising Russia and talking crap about Ukraine. So it's all making more and more sense. He must have some business dealings that rely on Russia doing well in the war. Because, I mean, these people are they don't give a crap. They have only loyalties to money. They don't care about anything else, anyone else, just themselves and money. For 3. There we go. It's either, what, you mean Russia, or, because I know there's some Middle Eastern interests, for sure. I'm not sure if it's just Qataris or what's the deal. I think it's Saudi more than anything. What happens if I chamfer this? Okay, I could still get like a chamfer between the blocks if I wanted to. But I think I'm going to start with this kind of design. So the problem with this though is there's not a lot of lateral grip, but there is a lot of like forward and back grip. So that'll be good. I kind of wish it curved, but you know, it's hard to print something. The printer does have limitations like going over, so I could make like little spikes or whatever, but I think this is adequate for now at least. But yeah, this will be good on sort of loose surfaces, and mostly, you know, forward and back grip, not so much side to side grip. Something that looks good. So if we go back and we turn back on like the knuckle, get the wheel back on. Here, just grab this guy. So there's the wheel and knuckle. And then we can bring in the subframe, the suspension arms, the inner bearing spacer, the axle hub. It's starting to look like a complete unit. Oh, the wheel is not big enough. It's barely the size of the subframe. Well, put your channel name along the tire wall. I might actually write it on after. Actually, this will be there'll be suspension actually, so we're actually okay. This will be drooping a bit. It won't be straight. It'll be angled. So that should be fine. But yeah, we probably need to make this version 2 a little bit bigger. But yeah, that's pretty neat. So the only thing we haven't touched today is the frame pieces. I don't know if I want to tackle the frame pieces, but we could. I'm curious to see how this will fit together. This universal joint is really, if that works, that'll be a sight to behold for sure. And theoretically, this end should be identical to the other end, and then you just put a spring in between with a stopper. So they'd be stuck. Well, thank you, Doug. I'm hoping to have this in operation shortly. I mean, we've got snow everywhere. It'd be really nice. I also need to work on the snow speeder. I kind of forgot about that. Oh, wait, this won't work. Hang on a sec. This can't work, because for this to tilt this way, there's too much slop. Oh, I don't know if this will actually work. Let's look at a socket. Yeah, I think the interior parts need to be a lot smaller. Oh, that's not good. I may have to figure out something different for the axles. Because I don't know if you know what I'm talking about, but like, let's say the hex right here, for it to move this way, you know, towards the right of the screen, it means this piece will need clearance. Like this edge, I'm gonna have to get rid of a lot of this stuff. Go away. Go away. Like this edge here needs to be able to get out of the way. That's a much more complex shape than I thought, actually. I'm gonna have to think about that. This won't work as is. So the thing is, there are already RC cars. Let me see here. But they might just be using commercial parts. I'm not sure. That kind of looks like commercial differential cups. Okay, so this is printed, but what about the drive shafts? CVD drive shafts. Oh yeah, they're using commercial drive shafts. I kind of didn't want to do that. The goal was to print my own, but so the issue is if this just takes forever, I mean, I won't be able to make it, right? Let's see. So if I grab so these drive shafts here, put it this way. So if you see, this is the knuckle design. This is what I kind of designed mine after, this sort of design. So this is like a universal joint here. See that? But that, you can't 3D print that. That's not going to happen. What you could do though is, I guess you could just use these drive shafts, but that was kind of, the point was to design my own. Let's see. What are people doing? This is where I need a mechanical engineer. What are they using in this? This is rear-wheel drive, so only the back. Sometimes they have like a BOM. They show you BOM as in BOM before. Only building services here. Oh yeah. Let me see. These, I think these are all, I think they all use commercial drive shafts. Yeah, there's no way that's printed, that's metal. I want to make sure that they don't think that I have a, give me a second here. they have a website? Okay, give me a second. I'll check. Okay. So yeah, so these are the drive shafts from that from the car I just showed you. So right now it'd be like 44 bucks, 50 bucks, and you need 4 of them. So you need 2 of these. So it'd be $100. Don't think that's it. These are, it's all, this is not good. Bill of materials, yeah. OpenRC website. I don't know where their website is. Maybe it was on the Thingiverse page, actually. Well, here's the build guide. Oh, great. Okay. It's not helping. So it looks like whatever is happening isn't happening anymore. The website is gone. Instagram, Twitter, Google+, Facebook. Is this even working still? Yeah. But does he still make videos? 2 months ago. Oh my god, there's a boat. Nice. Yeah, I don't know. I'm just gonna go drive shaft. See what we get. Okay, so this looks like that's a cool drive shaft, but that does not look strong. 3mm grub screws. Yeah, 1/16. I have to have a ponder. Because yeah, there are parts. But there's like, I'm just looking at how this is printed and there's no way, man. I do want something that's pretty rugged. So that's why I scaled everything up to be nice and big. But if I can't get the flexibility, I'm not sure. I'll have to mess around and see what I can come up with. Yeah, this is a classic style drive shaft. Hmm. Well, I'll have a think. Because I don't feel like... Oh, is this just... I wonder if I can just make it out of TPU. Like a bellows like this. Because the TPU is pretty solid. If I go... So this is the TPU I have. It's Overture. But like it collapses, but like it'll drive quite a bit of torque. I mean, maybe I could design something to print it out of TPU that would actually be strong enough. That would be a pretty neat joint. Like just something that allows for twisting, that it's like okay with twisting, but also with flexing. Because yeah, this is pretty crazy that you get a benchy boat that flexes like that and doesn't get damaged. I don't know. I'll have to have a think. Commercial axles are okay, I guess, but I have to adapt them to my setup too, which is not exactly the most fun, especially since I have these big bearings on here. Let's see. How about what was the biggest one? X-Max. See, these are some big boys. They look like they have a pin drive. Yeah, pretty sure they have a pin drive. Or are they pinless? Huh. I might just have to do some research. Look at this. Yeah, that's pin drive there. Might be able to make something like this. I just don't like having such a small pin move the entire thing, you know what I mean? I'll have to figure it out. I'll have to see. But I think it'll be time to end the stream very shortly. Starting to get really hungry. Yeah, these are pin drives. So look how complicated this has to be, how little material there's going to be in here. Because I could drive a bolt through here, right? So that's okay. And then this needs a corresponding sort of flat on the inside. I'm willing to try to make it, but it's going to be complex. And then this could just be a big hex. That's okay. I'll figure it out at some point. The way they usually work are these dog bones. So they have a cup like this, and then this comes through and it has a pin through it. I'm just uncomfortable with how big these things are to be sitting in a 3D printed part like that. Oh well, we'll figure it out. So I think this is where I'm going to end the stream today. I'm gonna go hunting for some food up in the old kitchen there. And yeah, thanks a lot for watching. This is probably my last stream until Christmas for sure. Boxing Day I should be around here playing Gran Turismo. So yeah, hope to see you guys in the next stream. Thanks for being here. Thanks for watching. And yeah, Merry Christmas to you all.